Okay, so we start off with corrections and we're looking at exercise 140, number 3. In this question, they ask us to find x, find the value of x. And what we'll say and realize is that the angles that they show in this diagram form a circle. So they are angles at a point or angles in a circle. So what we would do is we'd use that property, which is that angles in a circle sum up to 360 degrees. So what we would say is 4x plus 80 degrees plus x plus 3x will be equal to 360 degrees. And we put the reason as angles in a circle. Right? Angles in a circle. And we know that they sum up to 360 degrees. Okay, so that's really the reason for that. So what we'll do is add all the x terms together. So 4x plus x is 5x plus 3x is 8x. So we have 8x plus 80 degrees is equal to 360 degrees. So 8x will be equal to 360 degrees minus 80 degrees. Right, so we get 8x is equal to 280 degrees, and therefore x will be equal to 280 degrees divided by 8. Which gives us x equal to 35 degrees. Okay, so that's the answer there. X would be equal to 35 degrees, and that would be the answer you're looking at. Okay, so we're looking at exercise 140, number 9, and we are asked to find angle A. Now, what we tend to do here is to start to extend the lines to see if we could get anything that could help us, right, using the different properties. Because right now, nothing there will help us immediately. So one procedure we could do is to draw a line parallel to this top and bottom line going through this area here. Right, we can do that. And we could extend each of these lines like this, and we could extend this one like this, and see if we could get any assistance in solving this question. Now, one thing that I immediately see is that if we were to look at 22 degrees and this angle that I'm drawing here, which I will call angle theta, we could say that those two angles are alternate angles because they are inside of a special z. The special z would be, if I call here A, well, we already have A, so to make it a little easier, let's call here B. Right, let's call here B. So we're looking at B, C, call this point D, call here E, call here F. So we could speak about it easily. I'm looking EF, let's call here G, call here H. I'm looking at the Z form by going from B to C, C to D, D to H. I'm looking at that Z. And the angles inside of that Z would be 22 degrees at the top and theta below. those angles, because they are inside of that special z, which is from B to C, C to D, and D to H, we say that those angles are alternate angles, right? And they are equal. So theta will be equal to 22 degrees, and that's because they are alternate angles. Okay? And we could apply that same strategy to 32 and this angle I'm going to draw here. Let's call this angle alpha. Right? Call that angle alpha. So we say that if we look at the Z form by going from H to D to E and back to F, that Z formed is a special Z because it has the parallel lines G, H, and FE included and a transversal DE. So what we are saying is that the angle 32 and alpha are alternate angles as well. So alpha will be equal to 32 degrees, and again that's because they are alternate angles. So if we know theta is 22 and alpha is 32, then we should be able to work out what A is, because angle A from the diagram is equal to angle theta plus angle alpha. Right? A is equal to theta plus alpha, which is 22 degrees plus 32 degrees. So our angle A that we are looking for will be equal to, when we add them up, 54 degrees. So angle A is 54 degrees. Okay, so we're looking at number 10, exercise 140, number 10 now. Again, in this case, we'd have to look at how we could extend angles to help us. Right? What we know is that ED and AB are parallel. Right? ED and AB are parallel. So if we continue this line here and we draw another parallel line going through C, and we extend this one here, so we have this parallel line going out like this. What type of relationships are we able to find? Now, if we are able to find this angle here, if we are able to find that angle, then all we'd have to do is subtract it from 180 and we would get x. So let us call this angle here theta, right, and see what we could deduce. Now theta would be related to this angle inside here. In other words, this angle would also be theta, right? This angle here would also be theta because alternate angles. All right, it will be alternate angles. And if this here whole angle is 90, then we could find, we know that this angle here is 90 minus theta. We could get that angle, right? Or if we had this angle, we could get theta. And once we have theta, we could get x. So we just continuing working through. If we call this angle here alpha, we just naming it so we could talk about it. You could name it anything. We're just naming them so we could talk about them, and we know, everybody knows what we are talking about. If you observe, this angle alpha will be equal to this angle here, which will also be alpha, because again you have the special z's, right? This is inside of the special z, this is inside on the other side of the special z. That z being, if I call here L, L, C, D, K, if I call here K, right? We're just calling it letters so that we could talk about it. Okay, so I guess by now you see how we could solve it. Because if we know this is 140, we could find alpha by subtracting 140 from 80, from 180. Once you get alpha, you know alpha and alpha are alternate. Then we subtract it from 90 to get theta. And then we know alternate again. So we know what here is, and therefore we could find the angle x. Okay, so let me start writing down some items here so we could follow. Let us say that 140 plus alpha will be equal to 180 degrees, because those are angles on a straight line, right? So we just write angles on a straight line. Right? So therefore we can find what alpha is. Therefore, alpha will be equal to 180 minus 140 degrees. Okay? So that implies that alpha will be equal to 40 degrees. Okay, so we know therefore that this is 40. We know this is 40 because those are alpha and alpha alternate angles. Alright, so what we'll do now, we'll say that theta, the angle theta, will be equal to 90 minus alpha. Or we could just write something very simply. We could write that theta plus alpha is equal to 90 degrees. Right, from our diagram here. Theta plus alpha is 90 degrees. So, this is from the diagram. Right, so what we could say now is that we know alpha is 40. So, you could write theta plus 40 is equal to 90 degrees. And therefore, we could say that theta is equal to 90 minus 40 degrees. 90 minus 40 degrees, 90 degrees minus 40 degrees is 50 degrees. So we know theta is 50 degrees now. So if this here is 50, then this here is 50. Okay? So all we have to do now is find x, and we could say x plus theta is equal to, x plus theta is equal to 180. Just rub that off. X plus theta is equal to 180 from up here. And that's because angles are on a straight line. So you write that. Angles on a straight line. That's why I write that. So therefore, if we know theta is 50, I could write x plus 50 degrees is equal to 180. Okay, we should have put x plus theta on top equal to 180. Okay, so therefore we could say that x will be equal to 180 minus 50, and 180 minus 50 is equal to 130 degrees. So that would be the answer for this one. Okay, so in this question, there were many or more than one way that you could approach it. Alright, so this way is one way where you draw your parallel lines and you look for your properties of the various angles. And you know, you could, with practice, you could get many different ways to do the same problem. Okay, so we're looking at exercise 140, number 11 now. And we have to find angle A. So again, my procedure is extend the parallel lines. Alright, and you could even give them a title so you know what we're talking about. So we could call here B, C, D, E, F, G. Okay, so we could call it these things so we know. And let us extend this until we meet here and see what we could find. Okay. If we could find this angle here, and we could find this angle here, then in the triangle DEH, if we call this point H, in the triangle DEH, we will have two angles, all right, and then we could find angle A. But how would we go about doing that? Now in this GFHC, right, there's a special angle there that we could work on, and I'll highlight it. I'll highlight it in red so we'll see what we're talking about. Let us look at this. That's Z, right? That's a special Z because we have these two parallel lines, okay? And we know, we learned that this angle here will be equal to this angle here, right? We call that alternate angles, okay, in that Z. If you go back to your notes, you'll see that we studied that. And this angle here that I drew, that angle is 133 degrees. This one here is 133 degrees. Right? That's the angle shown there. So we know that the angle on the inside is also 133 degrees. So if for clarity purposes we call the angle on the inside here, let's call that theta. We could find what that is, right? By using all the fact that they are alternate angles. 133 and theta are alternate angles because they lie inside of that special Z. Okay? If we know what theta is, we could find what this angle is. Let's call this angle here alpha. Okay? We could find that by taking theta away from 180 because they now lie on a straight line, FE being the straight line. And then once we find alpha, and we know, let's call this one here beta. We're just naming it, angles that we could talk about. If we find beta and we find alpha, we just subtract the two of them, add them up and subtract from 180 and we'll get A. So let's do that step by step now, and let me write out all the different things that you need to put in order to get the marks, right? So let us say that angle theta is equal to 133 degrees, and the reason is that they are alternate angles. Right? Theta is equal to 133 degrees because they are alternate angles. We are looking at the Z form by going from G to F to H to C or D. That is what we show in red. Right? We have those two angles, theta and 133, they are alternate angles. Now, angle alpha plus angle theta will be equal to 180 degrees because these are angles on the straight line FE. So we write, the reason is that they are angles on the straight line, or a straight line. In this case, the line is FE, just for more clarity. So it means, therefore, that if we put theta as 133 degrees, theta as 133 degrees in this equation, we could write alpha plus 133 is equal to 180 degrees. So therefore, alpha will be equal to 180 degrees minus 133 degrees. That will give us 47 degrees. So if alpha is equal to 47 degrees, right, we have alpha equal to 47 degrees here now. We have theta equal to 133, that's what we got before. Beta now, let us find what beta is. 112 degrees plus beta must be equal to 180 degrees. Again, because these are angles on a straight line. And the straight line that we are talking about in this case would be the line BH. So therefore, beta would be equal to 180 degrees minus 112 degrees. You got 68 degrees. That will be equal to beta. So now we know beta plus alpha plus A in the triangle DHE would be 180 degrees. So we could write that beta plus alpha plus angle A will be equal to 180 degrees. And this is because angles in a triangle, the triangle we're looking at is DHE, are supplementary, which means they add up to 180 degrees. So beta plus alpha, we know beta is 68, we know alpha is 47, so we could write 68 degrees plus 47 degrees plus A is equal to 180 degrees. So all we have to do to find A, we'll subtract 68 and 47 from the left hand side. We have to do it on the right hand side as well. So A will be equal to 180 degrees minus 68 degrees minus 47 degrees. Right? And we'll solve for angle A. Which works out to be 65 degrees. And that'd be the answer that they're looking for. We are looking at exercise 114, number 12, and they're asking us to find the angles X and Y, given that AB and EF and CD, those three lines, are parallel lines. So if those lines are parallel, how can we evaluate X and Y? What we'll do is first extend the various lines where necessary so that we could see any relationship that will be beneficial to us. Okay, so we extend the lines and we'll put some further points so that we could identify things better. We'll call this point here O. We call the line here M, this point, call this point N. And let's call here P. So let's see what happens now. This angle here, if we call it angle theta, it is on the opposite side of an X as 32. So we could say that 32 and theta are vertically opposite angles. Then if we observe theta and Y, we could say that theta and Y are alternate angles because they lie inside of a special Z. The special Z is created by going from C to D, D to O, O to F. Okay? So therefore, in that way, we would have calculated what Y was. So let's proceed and get Y by saying 32 degrees must be equal to angle theta, seeing that they are vertically opposite. they are vertically opposite angles. Also, y and theta, those two angles are alternate angles because they lie inside that special z created by going from C to D, D to O, and then O to F. So we'll say that angle y must be equal to theta. The reason being that they are alternate angles. Okay? So angle y therefore must be equal to 32 degrees. And therefore that's one of the solutions that they are looking for. Angle y equal to 32 degrees. That's one of the solutions that we were looking for. Okay, what's the next thing that we have to find? We have to work out what angle x is. We have to work out what angle x is. So let's see, is there anything that we could do to help us solve that? If we were to examine this angle here, let's call that angle alpha. Then we could say that 50 is equal to angle alpha because they are vertically opposite angles. So we could write that immediately. 50 degrees is equal to angle alpha. Reason is that they are vertically opposite angles. Right, so 50 degrees equal to alpha because they are vertically opposite. Now, if we look at the z formed by going from B, let's call this point R, from B to R, R to C, C to M, that is a special z. So the angles inside of there will be able to help us, I believe, in what we need to find. If we find that angle inside of there, let's see if that will help us. So we find now angle beta by saying that angle beta is equal to angle alpha, and the reason is because these are alternate angles. Right? By looking at the special z, B to R, R to C, C to M, those two angles are alternate angles. And we know alpha is 50, so therefore we know that angle beta is also 50 degrees. Right? Angle beta is also 50 degrees. So if angle beta is 50 degrees, we could find the angle on the other side of angle beta. Let's call that angle that we are going to find now, let's call that angle gamma. Right? Therefore, if we say angle beta plus angle gamma is equal to 180 degrees, how come? Because they lie on a straight line M from M to D. This angle, if we go here and we continue on this side, beta plus alpha added up together will be 180 degrees because these angles are on a straight line. Okay, angles on a straight line add up to 180. So we could say that beta, which is 50 degrees, plus gamma is equal to 180 degrees. So therefore we could find what gamma is. 180 minus 50, which works out to be 130 degrees. So if we know gamma is 130 degrees, which is here, then all we have to do now is subtract 130 from 360 and we'll get angle x. Or we could write it like this. We could say that x plus gamma, angle x plus angle gamma, is equal to 360 degrees because they are angles in a circle or angles at a point. Okay, and we know this sum to 360. We just got gamma equal to 130. So x plus 130 degrees will be equal to 360 degrees. So therefore angle x would be equal to 360 degrees minus 130 degrees. Minus 130 on both sides. So therefore angle x will be equal to 230 degrees. Angle x will be equal to 230 degrees. Okay, so we are looking at angle properties of polygons, and the first theorem that we need to be aware of, theorem 1, says that you could write the sum of the interior angles of an n-sided polygon is, open brackets, 2n minus 4 multiplied by 90 degrees. That is theorem 1. Theorem 2. Next one is theorem 2. And this one is simpler. It says that the sum of the exterior angles of an n-sided polygon is 360 degrees. 360 degrees. So what does this mean? Let's check first of all a triangle. So if you're looking at a triangle, the sum of the interior angles would be given by 2n. n in this case would be 3, because a triangle has 3 sides. N-sided polygon, n means number of sides. So the n in the equation, in this case for a triangle, would be number 3 for 3 sides. So 2n minus 4 by 90 degrees. So we multiply that by 90 degrees. So it means for a triangle, the sum of the interior angles will be equal to 2 by 3 is 6. 6 minus 4 is 2. 2 by 90 is 180 degrees. And we know, even before we did this calculation, that the sum of the interior angles of a triangle is 180 degrees. Okay? This is an equation that enables you to work out the sum of the interior angles of any n-sided polygon. So for example, if we were trying to find the sum of the interior angles of a quadrilateral, whether it be a square, parallelogram, rhombus, kite, trapezium, what would be the sum of the internal angles? So for a quadrilateral, which means n equal to 4, the sum of the interior angles will be equal to 2 times 4 now, because in this case n is 4. 2 times 4 minus 4 by 90. Because remember, the equation is 2n minus 4. N in this case is 4 because it's a quadrilateral. And when we work that out, 2 by 4 is 8. 8 minus 4 is 4. 4 by 90, 360 degrees. So the sum of the internal angles of any quadrilateral, regardless of if it's a square, a rectangle, a rhombus, a parallelogram, a kite, a trapezium, all of them, when you add up the internal angles, they sum up or add up to 360 degrees. Therefore, in a question in the exam, they could present to you any polygon, right? Whether it be a triangle, a quadrilateral, or a 5-sided figure or a 6-sided figure, and you will know what the sum of the internal angles are. So if they give you 5 and leave out 1 in any form or fashion, then you will know what the total is. All you have to do is add up what they give you and subtract it from what you get as the total of the interior angles. So what we need to do is to get familiar with the names of these polygons. All right, so after a 4-sided figure, which is called a quadrilateral, there's a 5-sided figure. What is a 5-sided figure called? A pentagon. Very good. What is a 6-sided figure called? A hexagon. What is a 7-sided figure called? A heptagon. Right, we write it down just now. What is an 8-sided figure called? Octagon. 9-sided. A nanogon. And a 10-sided? A decagon. And let me go on, right? Okay. So let us write it down so you'll have it there. So if they tell you in a heptagon, so and so is the case, you'll know what it is. Okay? So you write 5-sided pentagon, 5-sided figure, pentagon, 6-sided hexagon, 5-sided pentagon, 6-sided hexagon, right? 7-sided now, it'll be heptagon, H-E-P-T-A-G-O-N, heptagon. 6 is hexagon, H-E-X-A-G-O-N. Okay, so pentagon, hexagon, heptagon. Now we go to 8. 8 will be octagon, like octopus. Octagon. After 8, 9-sided figure or polygon will be a nanogon. Nanogon. N-A-N-O-G-O-N, nanogon. And a 10-sided figure will be a decagon. D-E-C-A. Right? Decagon. Here, 10-sided is decagon. Now, triangles are very common in mathematics at this level. So we just, at this point, do a quick review of what we learned about triangles. Okay? The first thing is that we learned what a right angle triangle was. And a right angle triangle would be a triangle that contains a 90 degree in the triangle. So that's an example of a right angle triangle where we have a right angle in the bottom left-hand corner. Now that could be in any orientation. So this could be a right angle triangle too. But what is important is that there's a right angle in there somewhere. Like in there, that's 90 degrees. So it doesn't matter the orientation. Once you could locate in 90 degree within the triangle, it's a right angle triangle. Next triangle that is important is one that is known as an isosceles triangle. Okay? So what we studied here first of all was the right angle triangle. The next one that we look at is the isosceles triangle. And in the isosceles triangle, we have certain properties. The main isosceles triangle that we introduce would be one that is standing as shown with the base flat on the bottom and two sides are equal in length. We call the angle at the top the apex angle. In this case, it's the angle at the top. And the two angles at the bottom will be known as the base angles. So if we call this angle Y the apex angle, and we call this angle X one of the base angles, then the other angle will also be angle X, because the base angles will be the same, right? They will have the same magnitude. But we have to be careful of how we consider an isosceles triangle, because there may be an instance where they present a triangle to you where there's no clear base that you could identify. So if they present a triangle to you as shown in the diagram to the right, this diagram here, and they tell you, listen, those are my equal sides. They tell you, listen, where are the base angles? We cannot clearly identify a bottom position to say, well, those two are the base angles. So you have to know how to identify the base angles. And the best way is to identify it as those angles that are not the apex angle. The base angle are those angles that are not the apex angle. So we locate the apex angle first, and the apex angle is the angle formed where the two sides that are equal meet. Okay? So the two sides that are equal here meet at this point, let's call that point O, and the angle formed between them will be the apex angle. So if we call this angle Y, that will be the apex angle. So the apex angle is always where the two sides that are equal meet. And therefore the base angles will be the other two sides. Sorry, the other two angles. Therefore the base angle will be the other two angles. In this case, that will be the angle here at the top and the angle at the bottom. So those two angles marked as X, they will be the base angles. Okay, so you have to be able to identify your base angles when the triangle is not in the original orientation as we did initially. The next one that we do is something called an equilateral triangle. That's the next one that we look at. And in an equilateral triangle, the triangle is so constructed that all the sides are equal in length and all the angles are equal in magnitude. So if we have angle X at the top, we'll have angle X at the bottom as well. So we say that that is an equilateral triangle. What therefore should be the value of X in the equilateral triangle? What should be the value of X in the equilateral triangle? 60. It should have a value of 60 because we know the total internal angles, the sum of the internal angles in any triangle is 180 degrees. So if 3x is equal to 180, then x must be 180 over 3. So therefore x must be 60 degrees. So in an equilateral triangle, the internal angles are each equal to 60 degrees. Another very important point that is worth noting here is with reference to the right angle triangle. And in the right angle triangle, there's a special law that we need to be aware of, and it's called Pythagoras' theorem. Right? Pythagoras' theorem Pythagoras' theorem says that in all right angle triangles, and only right angle triangles, it doesn't hold for other triangles, in all right angle triangles and only right angle triangles, the hypotenuse squared is equal to the sum of the squares of the other two sides. So if we call one side side 1 and the other one side 2, then hypotenuse squared is equal to side 1 squared plus side 2 squared. This is Pythagoras' theorem. So if we were to do a very quick example, two examples as we have them on the board here, we'll call this example 1 and we'll call this example 2. If we were given a triangle A, B, C in question 1, whereby AB was 3, BC was 4, and we were asked to find the length AC, then we could say that from Pythagoras' theorem, since AC is the hypotenuse, it's a hypotenuse because it's the length of the longest side on the triangle, and it's also opposite the right angle. The side that is opposite the right angle is called the hypotenuse. So if we apply Pythagoras' theorem, which says that the hypotenuse squared, which in this case is AC squared, will be equal to side 1 squared. Side 1 could be either AB or BC. Let's say side 1 was AB, so that will be 3 squared plus side 2 squared, which in this case would be BC squared. That would be 4 squared. Right? The 3 squared was AB squared, and the 4 squared was BC squared. So we'll get that AC squared is equal to 9 plus 16. 9 plus 16 is equal to 25. So therefore AC will be equal to the square root of 25, which is equal to 5. Now it's really plus or minus 5, but you can't have the length of the side of a triangle as negative. So we'll eliminate the minus and say that AC is equal to 5 whatever units. So if the units here was centimeters, then AC will be 5 centimeters. Okay? So that's an application of Pythagoras' theorem that we need to be aware of. And then sometimes they word it a different way in an effort to make you do it wrong. So you have to be careful. For example, if they had given you L, M, N, and they told you that Ln was 5 and Mn was 4, and they wanted you to find ML, then you would have a little situation to work on. So let's say we were working that one. Let's say we had to find, in this case, ML. The secret of not getting it wrong is do not write down ML to start. Just go back to the original Pythagoras' theorem and write that down. So let us say in this triangle, the hypotenuse would be the side that is opposite the right angle, which would be Ln. So let us look at it from that perspective. Let us look at it from that perspective. So let us say Pythagoras' theorem in this case would say that the hypotenuse squared, which would be Ln squared, so you write it down, Ln squared, will be equal to side 1 squared plus side 2 squared. Side 1 in this case could be chosen as ML. So you write ML squared plus the second side, which would be MN squared. Okay? Pythagoras. Hypotenuse squared is one side squared plus the other side squared. Now in this case, we could substitute and say ln squared will be 5 squared. So you write that 5 squared will be equal to ml squared, which we don't know and we want to find, plus mn squared. Mn squared will be 4 squared. So you see the equation now looks different to what we had done in the first place. Right? So we'll have to solve for ml in that equation. So from this equation, we could write that 5 squared minus 4 squared is equal to ml squared. We'll minus 4 squared on the right hand side. We'll minus it on the left hand side. So 5 squared is 25 minus 4 squared is 16 will be equal to ml squared. 25 minus 16 is 9. So 9 is equal to ml squared. And therefore, if I want to find what ml is, I'll have to find the square root of 9. So the square root of 9 is equal to ml. What we did was take square root on both sides of the equation. And therefore, the square root of 9 is plus or minus 3. But we'll select 3 as the answer because we know the length cannot be negative. And therefore, the answer is ml will be equal to 3, whatever unit it is. So let's say the units here was centimeters again. It means that ml will be 3 centimeters. Okay, so that would be the two applications of Pythagoras' theorem that you need to be aware of. Now, the next thing we'll be looking at is quadrilaterals, right, in a little more detail, right, and for that you will give them a handout. So the handout that you have in front of you will give you all the properties we need to be aware of. Okay, so there are different types of quadrilaterals, right? What you see in front of you, the first one that is shown to you there is a trapezium. And a trapezium is a quadrilateral with only one pair of parallel sides. Okay? The next one is a kite. And the kite has two pairs of equal adjacent sides, one pair of equal opposite angles, diagonals intersect at right angles, one diagonal is bisected by the other diagonal, and two pairs of congruent triangles are formed by diagonals. Congruent triangles mean that they map exactly onto one another. Right? One will cover the other one exactly. The next one is the parallelogram, where opposite sides are parallel, opposite sides are equal, opposite angles are equal, diagonals bisect each other, and two pairs of congruent triangles are formed by the diagonals. That's a parallelogram. The rhombus has all the similar properties of the parallelogram, except that in the rhombus, all of the sides are equal. Okay, so you'd have all the sides being equal, and then all of the other properties of the parallelogram whole. The next one is a rectangle, and in a rectangle, all the internal angles are 90 degrees, and then it would have all the properties of a parallelogram. So a rectangle is a parallelogram where the internal angles are all 90 degrees. Then the last one is a square. A square is also a parallelogram. It is also a rhombus, but it is a particular rhombus. It is a rhombus where the internal angles are 90 degrees. Okay, and then you have all of the properties there. So those properties, you would require to study them and memorize them, because you would have to use them to solve questions like what we will do now. Okay, we are asked in this question to calculate the unknown angles. Those angles would be angle X, angle P, and angle Q. So we have to calculate angle X, angle P, and angle Q. We ask ourselves, out of angle X, P, and Q, Are any of them easier to find than the other one? Can we find any one easier than the other one? And the answer is not really. You can't really see an easy way to find any one of them. But the next question you would ask yourself is this. Is there any angle on the board in that whole diagram that you could find easily, even if it's not marked? Is there any angle that you could find easily, even if it is not marked there? Right, the one in the right-hand corner up here. Okay? And the reason is that this angle here that we just marked could be found by subtracting 13 from 90, because they are complementary. So if we call that angle angle Z, then we could work out angle Z. Now, having found angle Z, which was the easiest thing to find, even though they didn't ask you to find it, would that help us to find any angle? That's the next question you ask yourself. And the answer is yes. You could then find angle X because you know what the sum of the internal angles of any n-sided polygon is. So I'll illustrate by actually doing the calculation and showing you what I mean. So let's first find angle Z. We'll say that 13 degrees plus angle Z must be equal to 90 degrees, because from the diagram these angles are complementary. That is to say, they add up to 90 degrees. These are complementary angles. Okay, from that diagram. So it's very easy to find what angle Z is by saying 90 degrees minus 13 degrees. And that would give us the answer for Z, which would be 77 degrees. So even though they didn't ask us for it, we are finding it because we know if we find it, it could help us to work out the rest of the question. So what I'm saying now is if we look at the shape, if we consider the polygon, which is a quadrilateral, A, F, C, B. If we consider the quadrilateral A, F, C, B, then we know that the sum of the internal angles of this shape, which is a quadrilateral, is equal to 360 degrees. Remember, we just worked that out? 2n minus 4 times 90 degrees. We did that 2 examples. We did for a triangle, it worked out to 180. And then we did for any quadrilateral, and we worked out that it will be 360. So we know up front that the sum of the internal angles of any quadrilateral, for example, AFCB, would be 360 degrees. So that would tell us that we could say that 35 degrees, which is this angle here, plus x degrees, plus Z, which was 77 degrees, plus this angle here, Z was 77, this angle here is 90 degrees. All of these add up to 360 degrees because they are the internal angles inside of that quadrilateral. And we know that the sum of those angles in the quadrilateral add up to 360. We had studied that before. And even if you didn't remember, you could use the equation 2n minus 4 in brackets times 90. That would give us 360. So we continue. 35 plus 77 plus 90. Whatever you get, you have to subtract that from 360 and it will give us x. Or we could write it like this. X will be equal to 360 minus 35 minus 77 minus 90. In other words, we minus those numbers on the left-hand side and we also minus it on the right-hand side, right, to maintain the equality. So this is what it comes down to be. So therefore, angle X works out to be 158 degrees. Angle X is 158 degrees. So if we put it in here, 158 degrees, angle X worked out to be that. We can now find angle P. Look at where angle P is. Angle P and angle X lie on a straight line, which means that they add up to 180. So it's easy to find angle P by saying that angle P plus angle X are equal to 158 degrees. Sorry, 180 degrees. Sorry, 180 degrees. Okay? Now, angle X was 158, so we put that in. And therefore, we could find what angle P is by saying angle P is 180 degrees minus 158 degrees. Right? 180 minus 158 will give us the value for angle P, and you'll get 22 degrees. 22 degrees. Having gotten angle P equal to 22 degrees, what we'll do now is we could work out angle Q. How come? Because we know in the triangle FDC, when we sum up the internal angles, we must get 180 degrees. And we know what P is. We know 13, so the only unknown is Q. So we could write that, if we come up here, we can write that if we consider triangle FDC, that 22 degrees plus Q plus 13 must be equal to 180 degrees. Because we know that the angles in a triangle sum to 180 degrees. We know that, so we write it down. And therefore, we could get angle Q by saying 180 minus 22 minus 13. So angle Q would work out to be 145 degrees. Okay, so in that way we would have solved for all of the required angles. They wanted to know X, which we solved for here. So that was an answer. They wanted to know P. We solved for P here. So this here was an answer as well. This is an answer. And they also wanted to know Q. So this as well was an answer. Okay, so you solve all of those things for them. In this question, we are asked to find particular angles, but you observe that they state the angles in a different way, a different manner. So we have to understand what that way of writing an angle is, what it means. And the first one that we look at, which is this one here, is asking us to find angle LNK. That's what it's asking us to find, angle LNK. But you might be asking yourself, what is angle LNK? How do you identify that? To identify angle LNK, what we do is we start at L. So I'm going to start at L, go to N, because it's LNK, and then go to K. I won't go all the way to K. I'll just do as if I'm going to K. So it means I'm going to do this. And therefore, you could clearly see what LNK is by that movement. You could see the angle created by moving from L to N to K, can't you? Right? Look the angle right here. So this is the angle LNK that they want you to find. That is the angle LNK. So if they want us to find angle LNK, which could also be written like that. Okay? This could also be written like this. It's the same thing. The hat could go on top or on the side. How can I find that angle LNK? Anybody? Very good. We could find it by observing that the triangle KLN is an isosceles triangle because there are two sides that are equal in that triangle. In triangle KLN, there are two sides that are equal in length. The side KL is equal to the side LN. And we know that because of the double dash. The dashes or the double line on LN and LK say that they are equal. So if we consider the triangle KLN, consider triangle KLN, we say that that is an isosceles triangle. So consider triangle KLN. It is isosceles, right? And it is isosceles because KL is equal to LN. That's why it's isosceles. And where the two sides that are equal meet will be the apex angle, which in this case is 140 degrees, and the other two angles will be the base angles, and they will be equal. So it means the angle located up at K will be equal to the angle located down at N. In other words, the angle at K, which is 40 degrees, would be equal to the angle LNK, which is what you want to find. So we write that. Consider the triangle KLN. It is isosceles since KL is equal to LN. And 40 degrees must be equal to angle LNK because they are the base angles. Right? So in that way, we would have solved or found the answer for LNK. That's an answer. And at each stage, you must give your reasons. You see how we're giving reasons as we go along? At each stage, we must give our reasons. Okay, so our next step would be to find the other angles they're interested in. The other angles they're interested in is angle NLM. Where is angle NLM? Let's see if we can identify that, because we have to know what we want to find. Angle NLM will be go from N to L to M, which means go like this and then come down this side. N to L to M. That's what it means. Okay? So the angle they're talking about that they need us to find is this one here. That will be the angle NLM. NLM. That's the angle they're looking for. Okay? So how can we find that angle inside of there? Well, we could do it by noting something important. We could say that this angle inside of here, that angle inside of there, which would be angle NLK, right? NLK, we could find that angle. Let's find that angle. And if we subtract that angle from 140, we'll get angle NLM, which they're interested in. Now, angle NLK could be found by noting the fact that if we add up the angles inside of the triangle KLN, we'll get 180 degrees. So let's do that. If we still consider triangle KLN, we still consider that in this case, consider triangle KLN, we do it again. We say that if we add up 40 degrees, which is angle NKL, plus the other 40 degrees, which is in angle LNK, plus this angle here, which is angle KLN, we get 180 degrees because angles in a triangle are supplementary. That means angles Supplementary means add up to 180 degrees. Okay? So therefore, we could find what angle KLN is equal to. It'll be 180 minus 40 degrees minus 40 degrees, because we are minusing the 240s on the left hand side to get KLN, and therefore we have to minus it on the right hand side as well, and that will give us 100 degrees. So what they are saying is that angle KLN is 100 degrees. So I could put here as 100 degrees now. Okay? So you would realize that if you had the 40, and the 100, that will give you the 180 in the triangle KLN. But the reason we are finding that 100 degrees there, which was KLN, is because they asked us to find angle NLM, which is this. N to L to M. They asked us to find that. And we could easily find that now by recognizing that if we take the 100 away from the 140, we will get the angle NLM. So we could say that 140 would be equal to 100 plus angle NLM. That's from the diagram. Okay, 140 is equal to 100. This 140 here is equal to 100 plus NLM. So we could say 140 minus 100 minus 100 will be equal to angle NLM, which is what we're interested in, and therefore angle NLM will be equal to 40 degrees. Right? If you say 140 minus 100, you'll get 40 degrees. So that is the second one, angle NLM. So that's also an answer. And the last one we need to get is angle KNM. KNM. So let us identify where angle KNM is. If we look at K and M, it's like this. K to N to M. Right? So K and M means we're going along this line, hitting N and coming down here. So the angle that you're looking for is this angle here. That will be the angle KNM. That angle you're looking at there, inside of there. Okay? So how would we find that? Well, what I'm saying is we already know angle LNK, and if we were able to find the angle at the base of the triangle LKM, we'll be able to find the angle KNM. So let me identify this angle here as angle theta to make it easy to work with, and similarly this one as angle theta. Right? Let us say we are looking at the triangle LNM. We are looking at that triangle LNM. So we consider triangle LNM. Look at that triangle LNM. That is an isosceles triangle because line LN is equal to line LM. It's an isosceles triangle. And in an isosceles triangle, the base angles are equal. That's why we put theta as the two base angles. The apex angle in this case will be 40 degrees, which is what we calculated before for this angle here. So if we know this is 40, we could work out the two angles theta by recognizing that the triangle LNM is isosceles. So what we write is that 40 degrees plus theta must be equal to 180 degrees. Right? 40 plus theta must be equal to 180 degrees. Of course, we recognize that is theta, 2 theta, because it's isosceles. So then we write 40 plus 2 theta must be equal to 180 degrees. Therefore, 2 theta will be equal to 180 minus 40. 180 minus 40 is 140. And therefore, we could get theta by saying 140 over 2. And that will be equal to 70 degrees. So if we know theta here is 70 degrees, then we could find the angle KNM by recognizing that KNM will be lnk plus theta, which is 40 plus 70, 110. Therefore, the angle that we are looking for, which is KNM, will be equal to 40 plus 70, which will be equal to 110 degrees. And that as well was an answer.